Let's look at two more examples of converting non-terminating recurring decimals to the rational number form p by q. Here's our first example, 0.352 with a bar over 352. As we learnt in the last video, we equate this to a variable. So we can say that x equals 0.352, 352, 352 and so on. Let this be our first equation. To convert this to the p by q form, we need to eliminate the recurring part, which is this part. The only way to do that is to have two equations with the recurring part on the right-hand side of the decimal point. If we multiply this equation by 10, we will get 10x equal to 3.52, 352, 352 and so on. It won't work because we have different numbers on the right-hand side of the decimal point. What if we multiply the equation by 100? We will get 100x equal to 35.2, 352, 352 and so on. Again, the digits after the decimal point do not match. So let's multiply both sides of the equation by 1000. We get 1000x equals 352.352, 352, 352 and so on. Now the digits after the decimal points match. Let's make this our second equation. If we subtract this equation from this one, we will be able to eliminate the recurring part. Subtracting equation 1 from equation 2, we get 999x on the left-hand side, and subtracting this from this, we get 352. So x will equal 352 by 999, which is in the p by q form. Now, let's take an example of a mixed recurring decimal, 0.2394 with a bar over 94. This part is not recurring while this part goes on forever. First things first, let's equate it to x. X equals 0.23949494 and so on. We need two equations with the recurring decimal part. At present, we have none. We need to get 23 here to have just the recurring part on the right side of the decimal. Hence, we multiply this equation by 100 and get 100x equals 23.94949494 and so on. So we got the recurring part on the right side of the decimal. So let's call this our first equation. Here's the interesting part. How do we get another equation with the recurring part on the right side of the decimal? Yes, we multiply this equation by 100. So 10,000x will equal 2394.949494 and so on. Let this be our second equation. Now we are ready. We have two equations with the same recurring part. We could have got this equation by multiplying this equation with 10,000 too. It's the same thing. But remember, our only aim is to have two equations with the same recurring part here. Now it's simple. We can just subtract the first equation from the second one and find the value of x. The left-hand side would equal 10,000x minus 100x, and the right-hand side would equal 2394.949494 and so on, minus 23.949494 and so on. The left-hand side would equal 9,900x. Since the decimal part is the same, the right-hand side would equal 2394 minus 23, which equals 2371. So x equals 2371 by 9,900. Wow, all this takes time. What if there's a method by which we can write the answer directly in very little time? Yes, you will be surprised. In the next part of the video, we will see how we can arrive at an answer in matter of seconds. Until then, keep practicing hard.